Let us have a look at this bowtie script and how it works and what it outputs. So here I have basically copied into shell script in RStudio the code that you found in the module 8 document. And I've saved it in a file called bowtie2.sh in my module 8 folder. And notice I also have the an apptainer container in this same folder here, because when I run the bowtie software down here, I need to open this container file, right? And then run, in this case, bowtie build. So as long as my container file is in the same folder as my shell script, and I sbatch from this shell script, I don't need to put any path before the name of the zip file. But if the zip file is somewhere else, I need to tell the system where it is. But as long as it's in the same folder, you don't need the path. Okay. Yeah, so what is this shell script actually doing? We set some variables here. We use 10 threads. We have the contigs file, which we want to map against. This is the reference, you can call, that we are mapping our reads against. And we want to output everything to a folder on the scratch. And the first thing we're going to do now is to make an index. And if you saw my video on the Burroughs-Wheeler transform, you will understand what an index is. This is sort of a database where we collect the information about the genome sequence that we are mapping against in a very smart way, what we call the Burroughs-Wheeler transform and FM index. This is stored in this index. Okay. First thing we have to do, and this is a little bit special with the bowtie software, because bowtie, we said that the output should be in this folder here, and that's fine. We have to make that folder. If it doesn't exist, bowtie will not make it itself. Not all softwares will do that. You have to specifically make the folder yourself. And that's what we do here. The -p is for doing it recursively. So imagine you had specified a folder inside a folder inside a folder inside a folder. Then we will now create all the folders down to the bottom of that by this -p. Otherwise, it will only be the last one. In this particular case, we did not really need the -p because the scratch folder already exists, right? So we only make one step down, and that will be possible always. But I added here. Also note the if then else construction here, because bowtie is also constructed such that if there is already an index existing in this folder, it will not overwrite it. So we will not create a new index if there is already an index there. So what we actually do here, and this is perhaps a little bit dramatic, we say that if the folder exists, delete everything inside it. And that's what this means. rm for remove this folder, and *.* means all files inside that folder. And that's a little bit hefty, but okay, we can live with this now. But this is actually quite important, that you delete old stuff before you build a new index. Otherwise, the new index will not be built. You think you haven't made a new index and it's still the old one. And that can be leading to some serious errors sometimes. Okay, so here is the index building then. We use this bowtie build command, specify how many threads we need, then the input contigs like this, and then where do you want to store this? And that's over here, right? So actually what I will like to do now is to only run this first part of the script. So let me show you how you comment out code in RStudio. You just drag the mouse to highlight here, and you go to code and comment uncomment here. Then you comment out this section as if it's not there, right? And then we save the file. Remember to save the file. Always remember to save the file. And then we go out here and sbatch it to see what happens. So here I am now in this folder, LSA, or if you haven't made the LSA alias, see the end of module 5, how to do that. This is here I list the content of this folder, and we can see the same as we saw here. The shell script and the obtainer container file. So now we sbatch bowtie. And another trick, always when you're typing file names or folder names, type them halfway and use the tab button to extend. And why is this a good idea? Because if you have mistyped, let's say I type with a single V here and I press the tab, nothing is extended because you have there is no file starting with BOV here. So check that you can actually extend what you have started to write, then you have written it correctly so far. But it doesn't fill in the hole because you can see there are two files starting in the same way here. So now I need to say bowtie2 and .sh. So if I add a dot here now and then press tab again, then the system knows I'm talking about this file and not this file. Sbatch. And then we can look into the queue and see if it's running. Yes, it is. Here is the name of the job. This is my job. It's running and has been running for 6 seconds. This Jupyter Hub, you will always have that if you have RStudio running. That's RStudio. And that's been running for some minutes already. So as long as you have RStudio up and running, this will always be listed under Jupyter Hub. Notice the command I use here. This is also an alias. If you haven't made yourself this alias, you have to type SQ like this, and then it will be listed slightly differently with the partition as well. And the name column is not so wide, so you can't see the whole Jupyter Hub name. But it's basically the same information. Go to module 5 if you want to see how to do this one and this one. I think it was in module 5. So let's see, and you can use up arrow to repeat previous commands. So this is still running, and it takes some time to build this index now. And what I would like to do now, if I go back to my script here, the outdir, it's this one, right? This is where the output should be. Let me copy and go over here, and let's have a look at the content of that folder now. Like this. How does it look like? And here you can see we have started to build to make the index. And notice now there are several files here. All of them have the same start of the name, but they differ only in the end here. And this start of the name here is exactly what we specified here. Can you see that? The index is actually bowtie2 underscore index inside this folder. So all the files will have that as a start of their names, but then they will have different endings. And if we list it again by using up arrow, we can list again, and we can see there are more files. And all these called TMP are temporary files, so it means that this is still under construction. It's not finished yet. And it takes some time to build this index because this contigs file that we used as input was actually quite big. This was actually quite a big file with many contigs, so it takes some minutes to to actually build this index. Whoops. Stale file handle. That's something that you will see from time to time. It means that when the software is working inside the folder, it's continuously updated. So if you get this, just try again and it will most likely work. Yeah, it's still running. So we will just have to wait until this has finished. Okay, so now we can see that the queue has the bow tie is out of the queue. It's probably finished now. You don't see it listed anymore. So let's go and have a look into that Scratch folder again. And here we can actually see how it looks like in the end. The bow tie index consists of 6 files. It's always 6 files. They all have the sort of first part of the name specified with the same text as we used here. This is where we give it a name, you can say. But it's split over 6 different files. However, the name of the index is this first part here. So even if it's split over 6 different files, bowtie will understand which index we talk about if we name it like this inside this folder. So now we are ready to start mapping the reads to this index. And you can see the size of the files here. Actually, just let me show you. If you use a -h to the ls command, you will get sizes in a more human readable format. So you see it's megabytes. It's not super big though, right? Let's go back to the script and then comment in again the lower part here, because that's where we actually do the read mapping. So we highlight and go here again, because this will turn on and off the commenting. So now we turn it off again. And then we say, okay, we have built the index. Let's take these 2 files here and oops, I can see there is something wrong here. This should be R2 and not R1, both places. That's a typical error to make. You copy the first row into the second and you forgot to change from R1 to R2. And then you output to a SAM file. You can call it whatever you like. I chose to call it Illumina, and I put it in the same output folder as I specified up here. So I use that again, right? I output to this folder on Scratch. Here is the actual command line for mapping the reads then, and the command is bowtie. Again, we specify the threads. Let me split it into several lines, and remember, if you want to split the command line over several lines like this, always end each line with this backslash. Because here we now specify how many threads, here we specify the index, and then I make a new line here. And here we specify the R1, R2 inputs, because we have 2 inputs. You can have 3 or even more here. And then I make a new backslash, and here we specify the output to a SAM file this time. That's the one we specified there. Okay, now before I restart now, it took some minutes to build this index, and if I restart now, then this will delete everything in that out dir and start building the index again, and it will be the same index. So to save some time now, I actually comment out this part. I don't need to rebuild the index. The index is there. Let me now just use it. I mean, this is just something I do here and now to save some time, because I already run this code up here. Don't want to run it again. But it's not an error to do it. It just takes some minutes, right? So let's save this file. And like this, so it's no longer blue. And then we go back here and sbatch again. Actually, we can just use the up arrow. Why don't we use that? The up arrow, we can just click up, 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 until we see the old command that we want to run again. And now it's running again. And if we go over here, we should and refresh this window, we should see, yeah, this is the log file from the previous run, and this is from now. Let's actually open the one from the previous run, because it's a text file, but it contains quite a lot actually. And here you can see, if you scroll down here, it contains a lot. This bowtie build outputs a lot of stuff here. So, and if something goes wrong, you scroll to the bottom and see if you can find some error message. But I can't see any error message, and of course we know that it worked. So we don't expect to see any error message. And then we can actually delete this log file now. I do it here, like that. But this new log file is still empty, 0 bytes. It is not filled with anything. And that's some software will fill in something in the log file during their sort of work or computations. But other softwares are, like bowtie, will not say anything, send anything to the log file until it's finished. So this file will be empty until it's finished or crashes. Then it appears something there. But now we have to look at the queue again. I can up arrow here and see that bowtie is still now running. Has been for like 1 minute or so. And let's also have a look into this out folder there. And now we can see that the index is still there. And now we have started to produce this output file. And this one is growing during computation. So our bowtie will now map reads to the index, and for each chunk of reads it has mapped, it will extend this file with more results. So this one will grow. If we just repeat, we see now it's growing. It's 718 megabytes. Here it was 516. So this here you can sort of monitor that things are working by seeing this SAM file grow. And this can get quite big actually. And that of course depends on how many reads you have and how big genome you have. It actually depends on how big genome you have, or metagenome in this case. So we will actually just have to wait until this has done its job to see if this was working properly. Okay, so now we can see that the job has ended. There is no bowtie job in the queue anymore, with at least my bowtie job. So let's have a look at the output folder. And we can see that this SAM file has now grown to, okay, 4 gigabytes. Yeah, it's quite big. So this is a big text file. You should never try to open so big files, especially not in RStudio. It will not allow you. We can, however, have a small look into it. Let me make my window wider here, because we can at least inspect the start of the file. That could be a good idea. So let me, instead of listing the content, I use the head command to only list the first 10 rows or something. And I want to list this file. And note again, now I use the tab button. Let me see the content, the first lines of this file. And this is how it looks like. Yeah, it's not so excited in the start because it has some header section. Let's see a little bit further down. Okay, so this file has a lot of rows in the start here that I do not want to see. So let me look at the first 400,000 lines. But instead of looking all of these, because most of them, I only want to see the last of these 400,000 lines. And how can I do that? Let me show you. Then I pipe this into tail. And I only see the last 10 lines of the first 400,000. And here you can see, that's what I was looking for actually, the SAM format, the SAM file. It's actually a big table once you start to see the columns. And it has, I think it's 11, here it is, first row actually. So you can see it starts with the name of the file, and there is some numbers, and here's the config it mapped against, and so on. So each row here now is a position on this config somehow, where some read mapped. So this is actually a big text file, but we hardly ever look into it. But you should at least be aware that it's possible to look into it because it's simply just a big text file. But as you saw up here now, we had a lot of lines at the top that were not so interesting. So we took the first 400,000 lines and then piped it into tail. So we took actually only the 10 last. So from 399,990 to 400. Yeah. Okay. So this was not so exciting to look into this file, but at least you should know that it's possible to do that. What we actually should instead do is to go and look into the log file. Let me refresh here, because now this log file should be containing something. This is not big. The log file is not big. So this one we can click open and see it here in RStudio directly. And here you can see how small it is. And actually, this is one of the few cases where we like to inspect the log file even when things don't crash. Because here is a summary of how this read mapping went. So it says that this is the number of read pairs. All of them, 100%, were paired and reads. And here you can see that almost 64% align concordantly exactly one time. And what does it mean? Well, when you have read pairs, it means that the sort of the R1 read aligns to the left of the R2 reads and within a reasonable distance. So that's what is meant by a concordant alignment here. So 64% of the reads matched as they should, you could say, exactly one time. Some quite a big number matched 0 times concordantly, but of these, half of them matched discordantly. And that means they also matched, but not as we should expect them, because the distance was perhaps too big between R1 and R2 read. Usually we don't care too much about that. So what we actually look at is this total overall alignment rate, and 92% of the reads mapped here. And why not 100%? Because some of them have sequencing errors, right? Because now we actually use the reads to make some contigs, and then we take the same reads and map to the contigs. You should perhaps think that 100% should match. No, they should not, because some of them have sequencing errors, and during the assembly we have sort of filtered them out, which is why you never get 100%. And 92% is okay. This is fine, I would say. So look at the log file from a bowtie remapping to get some idea if something, because if this is super low, right, then something was wrong here. Then something was wrong. You have perhaps used the wrong index or something like that, the wrong read files. Because bowtie will not crash for that reason, right? It will just make a poor result. Okay, I think that's it for now.